Again, this is just one way to do this. You can also do this by hand. Now let's look at making the same exact confidence interval by hand. It's not quite as easy. We've already found our p-hat, which is the probability of success, which is our 856, was it? Over the 1228, which if we're going to find a p-hat and a q-hat, we might as well turn that into a decimal. So let's go ahead and round that off, and we'll get 0.697. And then we can also find our q-hat. Our q-hat, remember, is these are p-hats and q-hats are complements, so they have to add up to 1, so we can just take 1 minus our p-hat, so 1 minus 0.697, and we get 0.303. Now, remember, the next part is finding the margin of error and using that formula. But in order to do that, to use the margin of error formula, you have to find out your critical value, your z-value, for your confidence level, which means I need to draw a picture. And remember, our confidence level was 99%, and we'll need to find a z-value. So I'll draw my z-value, means I've got a normal distribution here. And remember, because it's a confidence interval, we have two ends. And the confidence level of 99% means that 99% is going inside the middle in the confidence interval. So in this entire center portion, this area needs to be 99%, or remember, we have to turn it into a decimal to actually use the area, which is 0.99. However, what does that mean about the ends of the same picture? Because we actually need the ends in order to find the z-value. Okay, because we want the z-value that's up here. We always want the positive one. Well, remember, if we've already used the 0.99 in the middle, that means that between both sides, it has to be the other 1%, or 0.01. But what does that mean about each piece, the top and the bottom, separately? Well, it means that each piece, if together they have to be 0.01, it means separately they have to be 0.005. Then the question becomes, how do I find that z-value? Well, remember, if we've got an area or probability where our picture is filled in like what we have here, if you want to find the z-value, you can, but you have to use an inverse norm function on your calculator. And remember, the inverse norm function always takes an area to the left. So be careful. If I'm using this picture the way I have it drawn, which is fine, I just have to be careful that I'm trying to find this z sub c value. I need the entire area to the left, which means not only the 0.99, but the 0.005 from this little piece at the end also needs to be included. So I need to add these two up. I need to add the 0.99 and the 0.005, which gets me a total of 0.995 to run my inverse norm on. Now, if you go ahead and go to your calculator, do your second distribution, do your inverse norm on this, what'll happen is you get your z-value, which is rounded out to, let's round it out to two decimal places, 2.5, let's see, 2.58. Okay, because you'll get, 2.575, which rounds to 2.58. And that is a z-value. That is your critical value that's going to get used in your error formula. So now you have all your values that you need. You have your critical value, your 2.58. You've got your p-hat, which is the 0.697. You've got your q-hat, the 0.303, and And you also need your n. We've already said that our n multiple times is that big number, the 1228. That's your total sample size. So we have everything we need to use our error formula. So let's go ahead and see. Remember, our error formula is not pretty. It looks like the following. E equals z sub c square root of p hat q hat all over n. It's messy. So let's go ahead and see what happens here. We already had our p hat. We said it was 0.697. We can input that. That's what goes underneath the square root first. And then we've got our q hat, which would come next, the 0.303. And then we would divide that by our n, the 1228. Then we have to take the square root of whatever that value is. So the first thing that we're doing is we're multiplying the 0.697 to the 3.303, dividing by the 1228, then taking the square root, then multiplying by our critical value at the very end, the 2.575 or 2.58, depending on how you rounded. When you're all done with all of your calculator doing all that heavy lifting for you, then what you end up with is your margin of error, your 0.034. Okay, what do you do with your 0.034? Okay, well, remember how the confidence intervals are set up with these p-hats, is that the p-hat goes in the middle. That means your 0.697 goes in the middle, and then you'd be adding the error. So you'd add the error to get the upper end, and you're gonna subtract the error to the p-hat to get the lower end. So we take the p-value, which is the 0.697, and like I said, we need to add the error to get the upper end, and we need to subtract the error to get the lower end. And when we do, when we subtract the error, we get the lower end, which was the 0.663. When we add the error, we get the 0.731, and that's the exact same confidence interval we got when we did this using the calculator. It just takes a little bit more effort.